I wanted to do a video about variation and a proportional change, which is section 5.8. And it comes from if you have a function that is, let me write down the function, like f of x is some constant times x to a power. That's going to be proportional to as the nth power of x. So it could be f of x varies as the square of x, or f of x is proportional to the cube of x, or whatever it might be. And I'll give some examples in a second. But similar to the last video we did, there was a formula about the length of the string of a pendulum and the time it takes to go from one side and back and complete one swing of the pendulum. The formula was that here, the time is equal to some constant times the square root of L. So it's proportional to the square root of L. And so they'll say that varies with the square root of the length. And so in that case, what happens is if you double the length, you put a 2 into the formula, and you get a square root of 2 times the time. And so in that case, if it varies with the square root of the length, you double the length, and the time increases by multiplying by the square root of 2. Conversely, we talked about on the right, if the length is equal to some constant times the square of the time, it varies with the square of the time, then if you double the time, then you increase the length by 2 squared, or 4. So if something varies with respect to the square of the input, if you double the input, the output is increased by 2 squared, or 4. If you triple the input, the output is increased by 3 squared, or 9. So that's what varying with the square means. And in general, what they say is so let's look at number 5 as an example. If y varies directly as the square root of x, what that means is you have a formula, y is proportional to x squared. And so you can write down an equation, y is k is some variable, some constant of proportionality, times x squared. And in order to find that constant, you can tell me some point. So when x is 4, y is 80. So I can plug that into my equation and solve for my constant. And so in this case, my equation would be y equals 5 times x squared. Similarly, they have like number 8. What about y varies directly as the cube root of x? So that would mean that I have an equation that y is proportional to, or k times, some constant times the cube root of x. And so if in this case they tell me that when x is 27, y is 15. So I can use that and solve again for the constant, and I get a formula. So this might be an example, like if I have a cube and I have the side is length y and the volume is x, then x equals y cubed, or y equals the cube root of x. And so in this case, the volume, so here, the volume varies as the cube of the side. So if I double the length of the side, my volume is going to increase by 2 cubed. If I double the side, the volume is going to be 8 times as much. Conversely, I could have the side is proportional to the cube root of the volume. So if I want to double the volume, I have to take the cube root of 2 times the length of the side. Think about that, and we'll talk through some examples. So in the book, they ask you to do all these things, like number 32 says y varies inversely with the square root. All that means is there's a formula that the y is equal to some constant divided by the square root of x. If it varies inversely, that means it's in the denominator. So what this is going to say is when x gets bigger, the denominator gets bigger, so y is smaller. So if it varies inversely, if you plug in a bigger number, you're going to get out a smaller output. And here it's as the square root of x. It could be varies inversely as x, or as the square of x, or as the square root of x, or whatever power you want. But again, that tells you how to set up a formula and lets you to solve for the constant of proportionality. So let me give you an example. They have a bunch of real world examples and lots of cases you can talk about. The input varies somehow inversely or directly, or with a square or with a square root, or with the length of the string. So this case says the vibration of a string under constant tensions varies inversely with the length of the string. If it varies inversely, that means a longer string, you're going to make a lower vibration. A higher vibration is going to be a shorter string. So the longer the string, the higher the vibration. And so you can set up a formula. The vibration, the number of vibrations per second, is proportional inversely to the length. So you get a formula that it's k divided by the length. And if you notice, you can change that formula around and solve for the length, and you get the length is also inversely proportional to the vibration. So if the vibration is cut in half, then the length has to double because they're inversely proportional. And you can use that formula and solve this, but you can also just intuitively, if the vibration in this example goes from 128 to 64, then the length has to be twice as long and it'll vibrate half as fast, half as quickly. And then in the homework, there are lots of other examples. So yours, for the homework, says the force by the wind on a plane varies jointly with the square of the velocity and the area of the plane. So what that means is you're going to have the force is proportional to the velocity squared times the area of the wing of the plane. And so you can set up a little formula and figure out if the velocity changes, how does that affect the force? If the area of the plane increases, how does that affect the force? And there's a proportion and there's a formula you can set up.